Alright, hello guys. I'm going to go over your quarter 3 exam review. Your quarter 3 exam is going to be on March 14th, Friday. It's going to consist of geometry and functions. I'd say about 20% geometry, 20 to 30% geometry, and functions is the remaining about 70 to 80%. Alright, let's go ahead and answer 1, 2, and 3 based upon this absolute value equation, absolute value graph. Let's start with whether this is a function. Yes, this is a function because for every x value, there's only one unique y. For example, if I'm looking at the x value of 2, that has one unique y, it being in this case 1. Let's look at 3. If we look at 3 as an x value, it has one unique y, which in this case is 2. So no matter where I go, for every x, there's only one y. You can also do your vertical line test. If I go from left to right, my red marker does not pass this absolute value at any point twice. Okay, so this would be a yes. Whether this is a one-to-one function, well, that's a bit different, right? For a one-to-one function, for every y value, there has to be one x value. So let's use an example here. If we look at the y value of 2, this y value of 2 has, well, an x value being 1. It also has an x value of 3 as well. Well, that's for one y, there's actually two x's. Well, in that case, this would be a no. This would not be a one-to-one function. Number 2, domain being from 0 to 3, let's take a look at what our range would be. Okay, so we're only looking from 0 to 3. What's the lowest point it goes and what's the highest point it goes, specifically from 0 to 3? Well, the lowest point it goes is at 1, and the highest point it goes from 0 to 3 is at 2. Okay, so the range for this would actually be between 1 to 2. Okay, what is our vertex? Well, our vertex being at 2 and 1, that would be our vertex. Now, we haven't had a chance to graph these, or based upon a graph with like you telling me the equation. In this case, real quickly, this would have an equation of x minus 2 and then plus 1 at the end. So this will be the equation of that. But don't worry about this too much. We haven't really touched that, we haven't really discussed that too much. But in this case, 2, 1 would be our vertex. All right, number 4. Number 4 is suggesting us for, well, it tells us f of x is equal to 4x plus 2. Our domain is -1, 3, and 5. Remember what images means. Again, it's asking us what the image set would be. Images, other words for images are y values, results, outputs, range. So we need to have 3 images based upon our 3 inputs. Okay, so let's do this one by one. When I plug in -1, again, my input, I plug in -1 back in. I'm also plugging in 3. I'm also plugging in 5. Okay, so we should have 3 outputs based upon our 3 inputs. -4 plus 2 ends up being, well, f of -1. When we input -1, we end up getting a -2 back. When we plug in 3, that ends up being 12. 12 plus 2 ends up being 14. When we plug in 3, our output ends up being 14. Our input's 5, that'd be 20 plus 2. This would be 22, so our input of 5 ends up getting us 22. We have our outputs of -2, 14, and 22. So this is exactly what our image set would be represented as. Okay, so here would be your answer. All right, for 4b, it's saying to us that f of x is equal to 10. It wants us to find our input, or our x in this case. Well, we know 2 things. We know f of x, like earlier, is that it's equal to 4x plus 2. It's also just suggesting that f of x is also equal to 10. Okay? Well, I know f of x is equal to 4x plus 2. I also know f of x is equal to 10. Well, I can set those both equal to each other. 4x plus 2 is equal to 10, minus 2 minus 2. 4x is equal to 8. X ends up being a value of 2. Okay? All right, so here we are at composition of functions. This is a pretty critical part of your test because, again, we're dealing with composition of functions. We're also going to be dealing with inverse as well, and a combination of both. So our first prompt, it tells us h of 4. Well, again, this would be your input of 4. Let's rewrite our equation of h. That would end up being 2x plus 2, the absolute value of 2x plus 2. And guess what I'm inputting? I'm inputting a value of 4. So I'm going to replace x with 4. Okay. I end up 2 times 4, it ends up being 8. 8 plus 2 ends up being 10. So that's the absolute value of 10. Well, what is the absolute value of 10? Absolute value of 10 is just 10. So h of 4 is equal to 10. Our input of 4 gets us an output of 10. All right, 5b. Again, just like last time, right? So what you're doing is you're inputting g of x in for h. Okay, so we know a couple of things. Well, first of all, we know g of x, right? G of x is equal to 2x squared minus 6. We're inputting g of x in for h of x, right? So the first thing I would suggest you to do is basically to write h of x, right? H of x ends up being 2x plus 2, okay? And guess what we're inputting? We're inputting g of x in for h, okay? So instead of saying x, I'm going to replace it with what g of x is, which is 2x squared minus 6. Okay, everything else stays the same, and I'm simply just going to simplify, right? 2 times this and 2 times that ends up being 4x squared minus 12. Okay, let's keep on simplifying. Negative 12 plus 2 ends up being negative 10. Okay, and that's it. I'm done, right? I've simplified this as much as I can. Okay, so this is your answer for h of g of x, right? I have put g of x in for h, so this is what your final answer should be. All right, 5c, again, same idea. F of x plus 2. My input is x plus 2. I'm putting that in for the function of f, okay? So again, what I suggest you to do is always write your function first and then replace your x with your input, okay? Function of f is 3x minus 5, okay? Well, I know I'm inputting x plus 2 in for that x, okay? Everything else stays the same. All you have to do is basically just to simplify, okay? This is going to distribute to both terms. I end up getting 3x plus 6 minus 5. Well, that will end up being simplified as 3x plus 1. So I know f of x plus 2 is equal to 3x plus 1. And you're done. All right, 5d. For 5d, I have the composition function of g of the inverse of f of x. So again, this is my input. I'm putting that in for g, okay? So what I should do first is write down g. Well, g ends up being 2x squared minus 6. And I'm putting, again, for that x, I'm replacing it with the inverse of f. The only thing is, I do not know that at this moment. So what I'll do right now, before I even do this composition, this composition, I will end up getting the inverse of f, okay? So I know f of x is equal to 3x minus 5. Again, f of x is the same thing as y, so if you want to replace that, be my guest, okay? I'm going to replace x, or I'm going to replace y with x, and I'm going to replace x with y. And now I'm solving for my new y, okay? So, I'm gonna add 5, x plus 5 is equal to 3y, divide by 3, I know that f inverse, okay, is equal to x plus 5 divided by 3, okay? So again, for that x, I'm going to replace it with x plus 5 divided by 3 since I found my inverse. Alright, so I will simplify everything else. Now, this is a bit tricky because I'm squaring this, also this as well, okay? So x plus 5 squared ends up being x squared plus 10x plus 25. Again, that 3 is being squared as well. Don't forget to square that as well. That's just 9, and then minus 6, okay? All right, now we can go ahead and start simplifying a bit more. I know this 2, again, I'm multiplying fractions here. So this 2 multiplies to here, here, and here. I end up getting 2x squared plus 20x plus 50 divided by 9 minus 6. Okay, and really, you can keep on going further, but this would be a nice way to kind of stop this answer. Okay, so you can stop your answer at g of f inverse of x. Okay, so this is what this composition function should be equal to. All right, 5e. I have f of h of negative 3. Again, tell yourself, I'm kind of working myself inside out. I'm plugging in negative 3 in for h. The result of this, I'm plugging that in for f, okay? So again, ask yourself, what is, when I put negative 3 in for h, what is the result of that? I'm going to take that result and put it back into f, okay? So first we have to find what h of negative 3 is. So h of negative 3, I know what h is, that's 2x plus 2. I'm going to plug in negative 3 in for x. Okay, let's find out what this ends up being. 2 times negative 3 is negative 6. Negative 6 plus 2. Well, negative 6 plus 2 is negative 4. And this absolute value of negative 4 ends up being 4. Okay, so I know h of negative 3 is 4. Okay, I'm going to take 4. I know the result of this is 4. I'm going to take 4. I'm going to plug it back in for f. Okay, so again, if you want, you can replace this with just the standard 4, since I know what h of negative 3 is. Okay, let's write down what f is. F is 3x minus 5. I know I'm going to replace x with 4, since that's what h of negative 3 is. Okay, 3 times 4 ends up being 12. 12 minus 5 ends up being 7. So f of h of negative 3 is equal to 7. Alright, 5f. For 5f, I know I have a composition function of h of g of f. Okay, so again, you can break this down in the way I've been kind of doing this. I'm putting f into g, right? And the result of this, I'm putting the result of that in for h, right? You work yourself inside out. So first thing we need to do is find out what g of f is first, right? I know, let's go ahead and write down g first. Let's end up getting what gf is first. So 2x squared minus 6. I know I'm putting f into g. Okay, what is f? Well, f is 3x minus 5. Okay, I've put f into g. Okay, so let's keep going with this. 3x minus 5 squared. Okay, let's see what that is. 9x squared minus 30x plus 25. Again, I just FOILed. Minus 6. Let's keep going with this. Distribute to all three terms. I end up getting 18x squared minus 60x plus 50, and then minus 6. Well, 50 minus 6 ends up being 44. Okay, so at least I know what GF is, right? I know GF is equal to all this. I'm putting GF right in for H, okay? So again, hold on to GF. Let's put that into H. Okay, so I'm gonna write down H. H is 2x plus 2, okay? I know I'm replacing this x with GF, okay? So 2, well, what was GF? GF ended up being 18x squared minus 60x plus 44. I replaced that for H, or sorry, for X. Okay, let's simplify as much as we can. We end up getting here 36x squared minus 120x, and then plus 88, 2 at the end. 2 plus 88 ends up being 90. Okay, again, we cannot simplify this any further. Okay, so H of G of F is equal to this. All right, 5G. We're getting a bit more complicated. Okay, so we have G inverse of F inverse of 4. So again, we need to find this value first before we put this in for G, or G inverse. Okay. All right. So there's a couple ways to do this. I will try to do this the simplest way I can show you. Right? I know I'm putting in 4 into F inverse. Okay, let's find out what the value of that is first. Okay, so let's write F first. Okay, again, we have to find what this value is first before we start doing anything else. I know I have y is equal to 3x minus 5. Again, this is what F is. So there's a couple ways you can do this, right? You can find out what the inverse of F is and then plug in 4, but the easiest way you can do this, again, since we're doing inverse, we can plug this straight in for y, right? And then find what the value of x is. So I'm going to plug this in for y. Let's see what we end up getting for F inverse of 4 plus 5, 9 is equal to 3x. I know x ends up being 3. Okay, so at least I know what this value is, F of inverse of 4. Okay, I know x is equal to 3. Okay, so I know this value is equal to 3, right? So basically what I'm working with here is G inverse of 3. Well, we basically know how to do that already, right? G inverse of 3, let's go ahead and write G down, okay? And again, where am I plugging this in? Since we're doing inverse, I can go ahead and plug this straight into y. Okay, and all I have to do is find out what my x element is. So plus 6, 9 is equal to 2x squared. Divide by 2, x squared ends up being equal to 4.5. Okay, if I find the square root of that and I square root of that, x ends up being equal to plus or minus. Again, square root in an equation, you have to do plus and minus of square root of 4.5. Okay, so this would be your answer. It would be plus or minus square root of 4.5. Okay, so this is equal to square root, or plus or minus square root of 4.5. So here's your answer. All right, 5H. I have G of F inverse of 7. Okay, And again, I need to do this part first. So I'm plugging 7 straight in for y for the function of f, right? So the function of f, again, let's rewrite that down first. F of x, I'll replace that with y, right, is equal to 3x minus 5. Again, the easiest way you can do this is just plug in 7 straight in for y, y in this case, right? Since we're dealing with inverse. Okay, let's find out what our x is in this case. Plus 5 plus 5, 12 is equal to 3x. X ends up being 4. Okay, so I know that f inverse of 7 is equal to 4. Okay, so I know this is equal to 4. Okay, well, what am I doing with 4? I'm plugging that into g, right? I'm working myself inside out. So let's go ahead and write down g, which is 2x squared minus 6. I know I'm plugging in 4 for x. Okay, again, do PEMDAS. PEMDAS tells you do your exponents first. So 4 squared is 16 times 2 minus 6. Well, which one do we do first? Do we do multiplication or subtraction? Multiplication comes first. So 32 minus 6. And what is 32 minus 6? 32 minus 6 is just 26, right? So g of f inverse of 7 is the following. It is 26. All right, 5i. We have g of negative a, right? So here's my input. I'm putting this in for g, right? There's no need to panic here. So you're simply plugging negative a in for g. Okay, well, the question is, what is g? G is 2x squared minus 6, so I'm going to rewrite that. For every x I see, I'm going to replace that with negative a. Okay, I'm going to rewrite everything else. Okay, well, let's follow PEMDAS here. PEMDAS tells us to do exponents first. Negative a squared is simply just a squared, right? I rewrite everything else. Okay, is there anything else I can do? Well, not really, right? There's nothing else I can simplify. These are not common like terms. So your answer of g of negative a is simply 2a squared minus 6. All right, for our final one for composition of functions, 5j, all right, we have f of f, right? Do not confuse this with f squared. You can refer to f squared, but that's not, you're not squaring f, right? You're putting f into f. So really what this is f of f of x, okay? It is the same exact thing. You're putting f in for f, right? So first thing we should do is write down what f is. Okay, I'm going to replace with this x with, well, f, right? I'm putting f in for f. So for this x, I'm going to replace it with itself, 3x minus 5. Okay, all we got to do is distribute. 3 times 3x minus 5 ends up being 9x minus 15 minus 5. Okay. So I know f of f is 9x minus 20. Okay, that's my final answer. All right, number 6. Find the value of x. Well, this problem comes up in number 7 as well, right? So our answer for number 6 should also match up with our answer for number 7. Now, when you're doing absolute value equations, you should remember that your absolute value has to be by itself. Okay, it's got to be by itself before you split it up into the positive situation and the negative situation, right? So even before you start splitting them up, I know I need to add by 2 to both sides. So I'll end up having a brand new equation. I'll end up having x minus 2 is equal to 2x minus 1. Right? Now at this point, I can split it up into both my situation. One situation is going to be positive, right? Or you're just going to leave it the way it is. So my first situation is going to end up being x, well, so we can get rid of this now. So x minus 2 is equal to 2x minus 1. The other situation, you're going to make negative, right? This is absolute value. It could be either of the two. So situation number 2 has x minus 2. That's going to stay the same. However, I'm going to have negative 2x minus 1, right? I just have to solve for each now. What we end up here having is negative x is equal to 1, which ends up being x is equal to negative 1. And for this one, there's a bit more work involved. X minus 2, I gotta make these both. This becomes negative 2x, this becomes plus 1. I add 2x, that ends up being 3x. I add 2, that ends up being 3. Well, and this ends up being x is equal to 1. Okay, you're not done yet, right? You need to check whether this works as well as this one as well, okay? If I plug back negative 1 in for this equation, I get negative 1 minus 2. That ends up being negative 3. The absolute value of 3 is just 3. If I plug in negative 1 here, well, that ends up being negative 2. Negative 2 minus 1 will ends up being negative 3. So you can already tell that this is an untrue statement. This is a false statement. So this will not work. Negative 1 is not a solution of this equation, okay? Let's check 1. If I plug in 1, 1 minus 2 is negative 1. So the absolute value of negative 1 is 1. Let's check back on this side. 1 times 2 is 2. 2 minus 1 ends up being 1. Well, this is true, so this checks out. So I know my solution of this absolute value equation is just x is equal to 1. This has been rejected, this has been accepted, so your only answer should be x is equal to 1. Alright, let's start graphing this. So I've got 2 lines to graph, right? I have the absolute value equation that I need to graph. I have this line I need to graph. And both of these equations I need to graph, making sure it's between negative 1 and 3. So negative 1 to 3, right? I have to make sure, again, this is my boss. It tells me it has to be between these 2 values. So since this is not a quadratic, I can use a table. So feel free to do that, right? Actually, I'll make 2 tables. I'll make one table for f of x is equal to x minus 2 minus 2. And I know my domain is between negative 1 and 3, right? The other table I'll make is for this line, right? y is equal to 2x minus 3, right? And I know it has to be between negative 1 and 3. Right? Okay. So I'll do the absolute value one first, right? The first thing you have to do is find out what your vertex is, right? Okay, so our vertex ends up being, well, x minus 2 is equal to 0. X minus 2 equal to 0, that ends up being 2. And take your outside, negative 2. Well, my vertex ends up being 2 and negative 2, right? So 2 and negative 2. That also falls within my domain, so we're still good to go. Let's plug in negative 1. Well, what do we end up getting when we plug in negative 1 in for here? Negative 1 minus 2 is negative 3. The absolute value of negative 3 is 3. 3 minus 2 ends up being 1. Okay, so when you plug in negative 1, we end up getting 1 back. Let's plug in 3, right? The other end of this absolute value. When we plug in 3, 3 minus 2 is 1. The absolute value of 1 is 1. And then 1 minus 2 ends up being a negative 1. Okay? Remember, I'm including negative 1. I'm also including 3. So this should be a closed circle. This also should be a closed circle. Right? So negative 1 would be right here with a closed circle. And 3 and negative 1 should be right here, again with a closed circle. So again, let's go ahead and attach these points. Okay. All right, I've got my absolute value there. Let's go ahead and graph our line now, right? Again, since this is not a quadratic, we don't have to get too bogged down with what this is, right? We can simply just plug negative 1, we can simply just plug in 3, and we should be good to go. When I plug in negative 1, right? When I plug in negative 1 here, I end up getting 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. When I plug in 3, I end up getting 3 times 2 is 6. 6 minus 3 is just 3, right? Again, both of these should be closed circles because negative 1 is included and 3 is also included. So negative 1 and negative 5. Okay, so negative 1 and negative 5 would end up being right here. And then 3 and 3, 1, 2, 3, would be right there, okay? So I'm going to attach these as best as I can. All right. Well, let's see what we end up getting, right? Again, I got as close as I could, okay? But this is how your equation should look like, right? And let's see, again, remind yourself what we ended up getting for the last problem. We got x is equal to 1. Well, did we get x is equal to 1? Well, we basically did, right? Close enough. Again, this is a sketch, so it won't be too perfect, but x is equal to 1. Well, what is x when, what is y when x is equal to 1? It's negative 1, right? So these both cross at 1 and negative 1. That's where their intersection point is. That's what their solution is, okay? As far as the range for this absolute value, we can go ahead and do that right now. So if we're considering the range, let's go ahead and read this, right? What's the bottom of this blue? Again, we're just looking at this blue line. What's the bottom of this blue line? Well, it stops at negative 2. The top of the blue line stops at 1. So the range, according to this domain, is between negative 2, including negative 2, and then including negative 1, or sorry, 1. So here's what our range should be, at least for this function, okay, this absolute value function. All right, for number 8, find the range for f of x is equal to x squared minus 2x plus 3 with the domain of negative 1, or between negative 1 and 2, right? So, remember, I cannot just simply use a table here, right? This is a quadratic. So if I simply just use a table, it's not going to tell me the whole picture, right? So what you need here is to basically graph this, go back to the second unit we did, right? Graph this as if we want to find the vertex first, right? Table will help at the end, but again, at least I want to find my key points of x squared minus 2x plus 3, right? So first thing I should do is try to find my vertex, right? How do we find our vertex? Well, it's between, we have to use this formula, negative b over 2a. Again, a ends up being 1 here, b is negative 2. So negative and negative, that will become a positive 2. And then a is just 1, so 2 times 1 is just 2. Okay, so this is the first part of our vertex. When we plug in 1, that's 1 squared, which is 1. 1 minus 2, which is negative 1. Negative 1 plus 3 ends up being a value of 2. So I know my vertex is 1 and 2, right? So 1 and 2, that is where my vertex is. Okay, now this is going to be going up. Again, this is a happy face because this is a positive, right? This is a positive. So this is a happy face. So I know it's going to be going up. It won't actually have any x-intercepts, right? So at this point and this point only, now you can start using your table, right? Because at least I know where the bottom of this quadratic is, right? I wouldn't get that necessarily by doing my table. Now it could, but ultimately you want to find out what the bottom of this parabola is. So let's go ahead and plug in negative 1, right? When we plug in negative 1 into this, that's negative 1 squared minus 2 times negative 1 plus 3. 1 plus 2 plus 3 ends up being 6. Okay, so negative 1 and 6. 1, 2, 3, 4, 5, 6. Again, that's a closed circle. It was included. When you plug in 2, right? Again, this is going to be included as well. It's including 2. When we plug in 2, 2, 2, let's see what we end up getting here. And that ends up being 4, negative 4, and then plus 3. This ends up being just 3. So 2 and 3 would end up being right here. Okay. So this is what we should end up with, right? Now, we could have also gotten the vertex by plugging in 1, right? When you plug in 1, we should still end up with 2, right? But sometimes that not always will happen, right? So you need the whole picture. Now we at least have the whole picture, right? We know how this quadratic is. Now, let's find the range, right? What is the range according to this domain? So according to the domain, again, domain is negative 1, between negative 1 and 2. Well, what is our range? Okay. Our range ends up being, well, the bottom of this is just 2. What's the highest it goes? Well, the highest it goes is up to 6, right? So I know it goes from 2 to 6. Again, I'm including 2 and 6 as well because it was included here. So my range should be between 2 and 6. All right, number 9, we have the absolute value of x squared minus 2x with the domain of between 0 and 3. 0 is included, 3 is not included, right? All right, again, take a step back. We're graphing a nonlinear within the absolute value, right? So the first thing I suggest you to do is, again, do not make a table for this. Your table will not tell you the whole picture, right? Sometimes it will, sometimes it won't. Really, you don't want to take that risk. So I want you to graph this. Your first step is to graph as if absolute value is not there, right? You need your vertex first. So really what you're looking for is your vertex. Okay, so this is a quadratic. Of course, it's going to have a vertex. So the question is, how do we find vertexes? Well, we find vertexes by using negative b over 2a. Again, what are we actually applying? We know x squared minus 2x. Again, without the absolute value, so I know a is equal to 1, b is equal to negative 2, right? So I'm going to plug in negative 2. Well, when I plug in negative 2 here, I end up getting negative 2 and negative on the outside. 1 ends up being 2 here. Okay, negative and negative, that becomes positive, so all I have is 2 over 2, which is just 1. So right now I have the x portion of my vertex. Again, that's going to go right around here somewhere, right? I need to find the y portion of my vertex, right? So what is the y portion of my vertex? Well, I need to plug in 1 in for x squared minus 2x, right? When I plug in 1, 1 squared is 1, minus 2 times 1 is just 1 minus 2. 1 minus 2 ends up being a negative 1. Right, well, great. I have found the vertex of this quadratic, which is 1 and negative 1. Okay? All right. I need to find the x-intercepts now, right? So that would be your second step. Find x-intercepts. Again, without absolute value. Okay? So, let's go ahead and do that now, right? How do we find x-intercepts? Well, we just make sure we plug in 0 for y. I'm plugged in 0 for y. What we end up getting here is, well, we can factor this. That's x minus 2 is equal to 0. Well, x is equal to 0. I also know x minus 2 is equal to 0. So that ends up being x is equal to 2. Let's go ahead and graph our x-intercepts, right? We know our x-intercepts now. X is equal to 0. Again, all these points fall within your domain, so you're still good to go. All right, now and only now can we start applying our absolute value, right? So let's go ahead and apply our absolute value. Well, actually, before I do that, let's go ahead again, make sure we have our endpoints. We still don't have the full picture yet. Now and only now can we start using a table, okay? When we plug in 0, again, now we can use your absolute value. 0 squared is 0, negative 2 is 0. Well, actually, we have that already right here. So when I plug in 0, I end up getting 0 back. Again, that's a closed circle. When I plug in 3, again, this should be an open circle now. When I plug in 3 in for this, that's 3 squared, that's 9. 9 minus 2 times 3 is 6, so 9 minus 6. That's an absolute value of 3, okay? So I should have an open circle at 3, 3. Okay, let's get rid of that. Okay. All right, now let's start applying the absolute value, right? Think about this for a second. Every value should be a positive, right? So anything that's negative, I'm gonna reflect up. I know this is 1 away from my x-axis, so this is going to reflect up here, right? It doesn't just go away, it has to reflect up into a positive value. So I have covered 0 and 3, 0 and 3 I've covered as my domain. I have found my vertex and my x-intercepts. Basically, I have the whole picture here. So this is going to look like this. Right? So considering our domain, we have to find our range now. Right? We have to find our range. Considering, again, we have the graph, let's consider our range. So our range is the following. Now we can start reading the graph. The lowest point this graph goes is at 0. Again, 0 is included. The highest point this goes is at 3. But again, 3 is not included, so this would be our range. Okay? All right, number 10. We've got f of x is equal to the absolute value of x squared minus 2x minus 2. Again, this is a nonlinear with an absolute value, so we got to treat this a bit differently. Can't just make a table. We can, however, make a table for this. This is a linear, right? Linear, nonlinear. We can make sure we can use a table for this. Should be good to go for that. It's all under the domain between -1 and 3. All right. So the first thing I'm going to do is graph f of x first, right? Again, you know your rule. I need to graph as if absolute value is not there. Okay. So, what do we need first? Again, I'm graphing x squared minus 2x minus 2 as if it's not under the absolute value. I need to consider my vertex first, right? I know this is how I find my vertex. I know A is equal to 1, B is equal to -2. So I'm going to plug in -2 here. Well, negative and negative makes positive, so this actually should be a 2. And A is 1, 2 times 1 is 2, so once again I have a vertex of 1, okay? Well, the x portion is 1. I need to go ahead and plug this back in. When I plug this back in, 1 squared is 1, minus 2, minus 2. This ends up having a y value of 3. Okay, sorry, -3. All right, so I know my vertex is 1, -3. Okay? Okay, so I need to graph the second portion now. So, well, I need to find my x-intercepts. So find x-intercepts of x squared minus 2x minus 2. Okay? All right. Again, once again, to find x-intercepts, we need to make sure that y is 0, so x squared minus 2x minus 2 is equal to 0. Now think about factoring this. Is this going to factor? Well, no, it's not, unfortunately, right? So if it doesn't factor, we have to resort to our quadratic formula, right? Quadratic formula ends up being, again, you need to remember this, -b plus or minus b squared minus 4ac all over 2a. Okay, I know I'm going to plug in the following. Actually, I might take a shortcut here and just simply tell you what you end up getting. I end up getting, well, a is equal to 1, b is equal to -2, c is equal to -2 as well. I plug those all in, and I end up basically having x equal to 2.73, and x is also equal to -0.73. Okay, so I know I'm plugging those in for my x-intercepts. And again, always check if it falls under the domain. It does in this case, so I know 2.73, I can plug that in, and -0.73, that would end up being right over there. Okay, now let's start using, let's go back to our domain, right? What else haven't we covered? Well, we haven't covered -1 yet. Okay, now we can start using our table under absolute value, right? So when I plug in -1, what do I end up getting as a result? When I plug in -1 here, I end up getting 1 plus 2 is 3. 3 minus 2 is just 1. Okay. When I end up plugging in 3, that's 3 squared, 9. 9 minus 6 is 3, and then 3 minus 2 is also 1. Okay. So I know 3 and 1. Again, I can include this. This should be a closed circle. This also should be a closed circle since I'm including -1 and 3. When I plug in -1, I get 1 back. Okay, so you can kind of see how this will end up looking like. All right. Now, one slight problem, right? This falls under absolute value. So now and only now can I start applying absolute value to what I have already. So this is going to reflect up 1, 2, 3 points. So I'm going to go up 1, 2, and 3 points. Okay, it doesn't just go away, it has to reflect up. So what I have here, I can start connecting these points. Okay, so this is at least how f of x looks like, right? Now for g of x, I can simply just plug in -1 and 3, and I'll end up getting basically how this line will look like, right? I can afford to do this because this is a linear, right? Can't do this for x squared minus 2x minus 2 under absolute value. However, if I plug in -1 for g of x, I end up getting -3 back. And when I plug in 3, I end up getting 9 back. Okay, so -1 and -3. Again, I'm including these since they're closed circle. And then I plug in 3, I end up getting 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I connect these points. Okay, so this is how this should look like, right? It does ask you the range of this blue graph for your absolute value. Okay, so your range should end up looking like, well, the bottom of this, again, we're only looking at the blue one. The bottom of that should be 0. The top, the highest it goes is 3. So the range of this should be from 0 to 3. All right, for 11. I've got g of x is equal to 2x plus 2, domain being between 1 and 3. I tell you to, of course, graph g of x, right? That should be pretty easy. Again, this is not a quadratic, so you can just simply use a table on your first go. Now, I need to also find the inverse of g, right? But let's find out what g is first. Again, I can use a table here. So again, this is, I'm graphing g of x, which is 2x plus 2, right? Okay, again, let's include 1. Again, this would be a closed circle. When I plug in 3, that also should be a closed circle. What do we end up getting? Well, when I plug in 1, I end up getting 4 back. And when I plug in 3, I end up getting 8 back, right? Let's go ahead and graph this first, right? So I'm graphing g of x first using these 2 points, 1 and 4, and 3 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is how g of x, again, I put this in blue. Again, that was 3 and 8, and that was 1 and 4. Okay, so for the inverse of g, right? Let's think about this for a second. What does inverse mean? Well, I'm switching x and y's. Well, I have my coordinates already. I can switch 1 and 4 to be 4 and 1, and I can switch 3, 8 to be 8, 3, right? So let's go ahead and put this in red so we can see the difference between the two. I know I'm plugging in 4, 1. Again, these are closed points like I had last time. I know I'm considering 8, 3. So 1, 2, 3, 4, 5, 6, 7, 8. 8 and 3. Okay. Again, that's 8, 3. And I have 4, 1, right? Your question asks you basically to figure out what your domain and range is for both, right? So I have domain up here and range here, and I'm considering what g of x is and g of -1. Right? Let's take a look at what our domain is. Well, I told you what your domain is initially of g of x. That's 1 between 1 to 3. Let's figure out our range. Again, this is in blue for g of x. Right? Again, this is g of x. So our range, right? The bottom of this line is at 4. The top of this line is at 8. So the range is 4 to 8, right? Let's consider our g of -1, right? Let's consider our inverse. Let's consider our domain first. So I'm going from left to right. I can from left to right, it's 4, and it stops right at 8. So 4 and 8, right? Let's consider our range. Again, the bottom, the lowest point it goes is at 1. The highest point it goes is at 3. So 1 to 3. Again, that's range, so use y. Okay. I have g of -1, my inverse, and I have my original function of g. Okay, notice what happened here. Your domain and range switched, right? And your range and domain switch just like how this and this switched as well previously, right? So I have my domain range for g of x and inverse of g presented here.